Yes, student. Now I defined you half range Fourier series. Okay. Actually, a half range Fourier sine or cosine series is a series in which only sine terms and cosine terms are present in a half range. Okay. Therefore, in half range series, yes. Therefore, in half range series, the functions, okay, the functions is generally defined in the interval 0 and pi, okay, instead of minus pi to pi, okay. And therefore the sine series, now we define the sine series and cosine series in 0 pi. Yes, first one we have defined the sine series, okay, the sine series in 0 pi, okay. Now we construct a function f of x which is defined as f of x, yes, for this one. We construct a function f of x which is defined as, which is equal to f of x, yes, let f of x is equal to f of x for 0 is less than x is less than pi, and which is equal to minus of f of minus x for minus pi is less than x is less than 0. Yes, here we see that here we see that the for f of x minus of f of x, that is for odd term, yes, which is odd function. So the f of x is in the interval, yes, this for the f of x for 0 to pi, but for minus of f of x, minus of, that is the odd function, yes. So the f of x defined is an odd function. So f of x is an odd function. Yes, clear. With the interval 0 is less than x is less than pi. So f of x, the Fourier series, which can be defined as sigma n is 1 to infinity bn sine nx. Okay, where we know that bn, yes, because you get only the odd functions, so you find out the series in the form of, earlier we have defined the series of the odd function, we get only this one series, yes, where we know also that, yes, where bn is also defined earlier, 2 by pi, yes, 0 to pi f of x, yes, f of x sine, yes, nx dx, yes, for n is greater than equal to 1, for 0 is less than x is less than pi, yes. Similarly the series for the cosine series, yes, next one, second one, yes, the cosine series, the cosine series in, similarly the cosine series in the interval 0 pi. You can also obtain, as we get the sine series, here we construct function, let f of x, yes, let f of x which is equal to f of x for 0 is less than x is less than pi, and which is equal to f of minus x for minus pi is less than x is less than 0. So the function f of x is an even function, yes. even function with f of x in 0 is less than x is less than pi. Okay. Therefore, for the even function, we get f of x is equal to half a0 plus sigma n is 1 to infinity a n cos nx. Yes, and where a0 and a n you also know. Okay, this is the Fourier series in 0 pi. That is the half series. Yes, student, I think you have cleared this sum. Yes, similarly, I can obtain the Fourier series in the interval 0 to 2 pi. Yes, the Fourier series. Yes, Fourier series in the interval 0 and 2 pi. Yes, here to find out this series, we use for the function which is in 0 to 2 pi. So let us take a substitution which is y. Let us suppose that any function in the raised minus pi, we can take y is equal to, let y is equal to px plus q when x is equal to 2 pi, and when y is equal to minus pi. Yes, and y is minus pi when this is equal to, not here is minus of pi, when this is minus of pi when x is equal to 0 and y is equal to pi. Therefore, from here you substitute, here is minus pi, x is equal to 0. Yes, then y is equal to pi, you see here from, and also from, so you get y is equal to, yes, minus pi, then this one. So minus pi is equal to, y is minus pi, so this is equal to q. X is 0, so this one is minus pi, then this become q. So you get pi here is, pi is equal to 2 pi, p substituting value, and q 2 pi p plus q, or we say this implies that y is equal to, you get x minus this one, q minus pi, that is you get y is equal to x minus pi, like that. Okay. For the Fourier series, for this term you are using. So applying this, yes, so the function f of x we define in terms of y as f of x is, you have cleared it. Yes, let f of it, this is equal to x plus 2 when x is 2 pi, and is equal to minus of pi when x is 0 and x is pi. So substituting this, you get is equal to 0, then you get this one. Yes, and also for 2 pi you get this one. So you pi substituting the value of pi. Yes, for here if you pi substituting, then p is this one and q plus q. Yes, so we take the substitution as this one, and now converting the function f of x as this one, you suppose that f of x plus y is equal to f of y function. F of x, if we substitute in the terms of x plus, x not in, here you take x as x is equal to pi plus y. Yes, you will take this term. So this term become in y. Yes, and therefore f of y, which is equal to a0 plus sigma n is 1 to infinity, and a n cos ny plus sigma n is 1 to infinity bn sin ny. Yes, and where we know that a0, you know that earlier, a0 is 1 by 2 pi minus pi to pi f of y dy. Yes, if you substitute here, f of y is here, so substituting if you here, x is equal to this one, your dx is equal to dy, so this you become this is again become 1 by 2 pi. Yes, and now here the xy is equal to x minus pi, so taking this limit, so here is minus pi, if you take y is minus pi, then x becomes 0. If you substitute here pi, then x become 2 pi f of x dx. Similarly, and an, yes, similarly an you can also find out 1 by pi, you know that this result, minus pi to pi f of y cos ny dy. Okay, here you also now substituting the same term, this one, so this become minus, yes, 1 by pi, limit from 0 to 2 pi, and here is f of x cos n x minus cos, here you substitute x minus pi dx. Okay, now you apply the formula cos a cos b cos this one cos this minus plus sin a sin b, so sin pi which is 0, so you get the term commonly cos of n pi, yeah, this term, so you get minus 1 to the power n, the value of this one, divided by pi 0 to 2 pi, and you get f of x cos nx. Yes, clear? Similarly, you can obtain also bn, you can also obtain, yes, you can also obtain, yes, here is bn. See, similarly you can obtain bn is again minus pi to pi, yes, 1 by pi, and this is f of y sin of ny dy. Now again substituting the term, you get this is again is equal to 1 by pi minus pi, that is substituting this one, then this is 0 to 2 pi, yes, f of y, so the function is, this is also again become f of y, and this term is sin of n, yes, x minus pi dx. And now substituting sin a cos b cos b cos a sin b, applying this, you get the resultant value is minus 1 to the power n by pi 0 to 2 pi f of x sin nx dx. Yes, student, so for this kind you know the results of for the interval 0 point, you know that a0 an bn. Okay students, thank you. Next video I have defined some other terms of the Fourier series. Yes students, thank you.